In 1905, the great scientist Albert Einstein discovered in his youth a great theory that changed the course of physics, which was known as the theory of relativity, which is divided into general relativity and special relativity. This simple theory explained many wonderful things. For example, the space and time and its curvature, the relationship of mass and energy, the light and time, and the mechanism of the movement of light and the curvature of spacetime, which will be our topic today for this video. This is a wonderful theory that explains a lot of things about the secrets of the universe. Einstein won a Physics Nobel Prize in 1921 for this subject. He wrote about the photoelectricity effect and the special relativity. And actually, that brings us into a question. Can we trust our eyes and what we see in the universe? What is the relationship between the light and the space-time? Well, we will talk about it now. Our topic today talks a lot about the mechanism of light. The more we talk about the topic of light, the more things about gravity and time becomes clear to us. Before we start with the topic, let's clarify a few things about light. Light, by its nature, is a massless particle, and the particle that makes up the light is the photon. If you look at the particles table, we will notice that a photon is the only particle out of all the particles in the table that does not have mass, plus the gluon particle, of course, that represent to us the strong nuclear force. There were differences about whether the photon is a particle or a wave. After many differences between scientists, Einstein declared, using special theory of relativity, that a photon possesses both wave and particle ability at the same time. There's an important question. Its answer shows us two processes of electromagnetism and weak nuclear force at the same time. The question is, how does the photon form in subatomic world? Well, we know that in chemistry, atoms have different atomic levels, which describe the number of electrons in each atomic field. And when there's a disturbance in the energy of electron, energy will be released and the disturbance inside the atomic will end. The photon is formed when electron moves from the higher level to a lower level, and it will release energy from itself in the form of electromagnetic wave, which is the photon itself. And the same process is reversed if the photon particle collides with the electron, and it will rises to a higher level. And this is how we get a photon. As it is known in physics, light is the fastest moving object in space. The speed of light movement in the vacuum is 299,792,458 meters per second. In other words, light moves at speed of 1 billion kilometers in 1 hour. To simplify, it took 8 minutes for the sunlight to reach the Earth. There is nothing in the universe that can move at this speed, except for massless objects like photon. However, if the photon is massless, how does it bend in the gravity and fall into the black hole? Well, the theory of relativity says that gravity has the force to make light or an electromagnetic wave bend in the space-time, so the light will bend in another direction. This process causes a condition called the Einstein ring, in which the light bends when it is launched from the source, and the light moves around the large mass objects, and that's where the light bends around it. This process is divided into the source, lens, and the observatory. The light moves from the source to the observatory naturally, but when it passes through the lens, which is a high mass object, for example a galaxy, then the light will bend, and when it reaches the observatory, we will get this image. This process is represented by an equation called the Einstein radius. In the equation, we see the gravitational constant here under the radical beside the mass and above the squared light velocity here. The unit mass here represents the mass of the lens, meaning the mass of the object between the observatory and the source. The distance between the observatory and the lens is called the dl. The distance between the lens and the source is called dsl. And the total distance between the observatory and the source is called ds. If dl is 4 billion light years and dsl is 3.5 billion light years, as a result, the ds will be 7.5 billion light years. We divide the data among themselves and convert the units into their numbers. For example, the gravitational constant here is equal to 6.674 times 10 to the power minus 11. And the mass of the lens or massive object, for example, 3 times 10 to the power minus 11. After simple mathematical stage, the equation will end and you will have the result, which is the radius of Einstein. Why the speed of light included in the relativity equation? And what is the relationship to space and time? As you can see, the letter E here represents energy for us, and the M here represents the mass, of course. This equation represents for us the combustion process and the brightness that occurs from the stars. In the equation, energy turns to mass and travels at the speed of light. This is what causes the star to shine and light up. So, the greatness and beauty you see in the night sky, all of its processes are described in this single equation. The special relativity equation describes many things about the movement of light in a vacuum. The faster you move, the more slower will time get to you, and as you reach the level of light speed, time will stop. So it is impossible to go back in time because nothing's moves faster than light. These descriptions all come from this simple equation. Einstein is a genius to discover this greatness and summarize it into one equation. This discovery is so great that Einstein has become an example of intelligence. In the previous videos, we talked about the Big Bounce and is it infinite? By the way, is infinite possible and present in our universe? Has physics explained it before? Well, we will leave this topic for another video. Until that day, do not stop wondering and be curious.